Have you ever wondered why you can push yourself to achieve incredible goals one day, but the next day you can't even get out of bed? Or why scrolling social media for hours feels irresistible, even when you know it's harming you? The answer often lies in a tiny chemical in your brain called dopamine, and it's far more powerful than you might think. Dopamine is often called the feel-good neurotransmitter, but that's only part of the story. In reality, it's the hidden driver behind motivation, focus, habit formation, and even addiction. It's what pushes you to chase goals, learn new skills, and take on challenges. But it's also what traps millions of people in cycles of compulsive behaviors, from binge eating to social media scrolling, gambling, and substance abuse. In this video, we're going to break down the science of dopamine in a way that's simple, visual, and practical. You'll see how your brain's reward system works, why it craves anticipation more than actual pleasure, and how this chemical shapes nearly every decision you make, often without you realizing it. By the end, you'll not only understand why you feel motivated or unmotivated, but also how to hack your dopamine system to build better habits, stay focused, and avoid the pitfalls of addiction. Whether you're chasing personal goals, seeking to break bad habits, or just curious about how your brain really works, this video will give you the insights you need to take control of your mind. So, if you've ever felt like your brain is working against you or like you're stuck chasing things that never truly satisfy, stick around. What you're about to learn could change the way you think, act, and live. To truly understand how dopamine drives motivation, habits, and even addiction, we first need to look inside the brain and understand what dopamine is and how it works. Dopamine is a type of neurotransmitter, a chemical messenger that allows neurons to communicate with each other. Unlike the electrical signals in your nervous system, neurotransmitters are chemicals that travel across tiny gaps called synapses, carrying instructions from one neuron to the next. Dopamine, in particular, plays a key role in reward processing, learning, movement, and emotional regulation. Dopamine-producing regions. Dopamine is produced mainly in two areas of the brain: the ventral tegmental area, VTA, and the substantia nigra. The VTA, located deep in the midbrain, is part of the brain's reward circuitry. It sends dopamine to several critical regions, including the nucleus accumbens and prefrontal cortex, both of which are heavily involved in motivation, decision-making, and emotional responses. The substantia nigra, also in the midbrain, is primarily responsible for movement control. This is why dopamine deficits in this area are linked to disorders like Parkinson's disease, which causes tremors, stiffness, and difficulty with voluntary movement. These areas are connected by dopamine pathways, highways along which dopamine travels to deliver its messages. The four major dopamine pathways. Understanding these pathways is key to grasping how dopamine affects behavior. Mesolimbic pathway, often called the brain's reward pathway, it connects the VTA to the nucleus accumbens. This pathway is central to motivation and the feelings of pleasure associated with rewards. Whenever you achieve something satisfying, completing a project, eating a delicious meal, or winning a game, this pathway lights up with dopamine. Mesocortical pathway. This pathway links the VTA to the prefrontal cortex. It plays a major role in executive functions, such as planning, decision-making, and emotional regulation. Dysregulation here can contribute to impulsivity, poor decision-making, and certain mental health disorders. Nigrostriatal pathway, running from the substantia nigra to the striatum. This pathway regulates movement and coordination. Damage or dopamine deficiency here is the hallmark of Parkinson's disease. Tuberoinfundibular pathway, extending from the hypothalamus to the pituitary gland. This pathway controls hormonal functions, such as the regulation of prolactin, which influences reproductive and metabolic processes. Dopamine's role beyond feeling good. It's a common misconception that dopamine's main function is to make you feel pleasure. While it contributes to enjoyment, its primary role is actually motivation and learning. Dopamine spikes when we anticipate rewards, not just when we receive them. This anticipatory surge is what pushes us to take action, seek opportunities, and repeat behaviors that help us survive and thrive. This mechanism also underlies reward prediction error, a fundamental concept in neuroscience. When an outcome is better than expected, dopamine neurons fire strongly, signaling that we should repeat the behavior. When it matches expectations, firing remains neutral, and when the outcome is worse than expected, dopamine firing decreases, discouraging the behavior. This system teaches our brains what to pursue, what to avoid, and how to adapt to a changing environment. Dopamine receptors. Dopamine doesn't act alone. Its effects depend on dopamine receptors, proteins on neurons that detect the chemical and trigger cellular responses. There are 5 main types, D1 through D5, each with specialized roles in movement, motivation, memory, and learning. The sensitivity and number of these receptors can change based on genetics, experiences, and lifestyle factors, which helps explain why some people are more prone to addiction or motivation deficits than others. Dopamine is the brain's messenger of motivation. It flows through complex networks, reinforcing behaviors, guiding decisions, and shaping habits. By understanding its biology, we begin to see why it is both a source of drive and a potential vulnerability. The pathways, receptors, and mechanisms of dopamine set the stage for how humans learn, strive, and sometimes fall into addictive cycles. Dopamine is often misunderstood as simply the pleasure chemical, but its true role goes much deeper. Rather than just making us feel good, dopamine is fundamentally about motivation, drive, and the pursuit of goals. It's the invisible force that propels you to take action, overcome obstacles, and chase rewards, even when the effort is challenging or delayed. Motivation versus pleasure. The distinction between pleasure and motivation is crucial. Pleasure, or liking, is the enjoyment you feel after achieving a goal. Motivation, or wanting, is the urge to pursue that goal in the first place, and that's where dopamine shines. Neuroscientists have discovered that dopamine spikes not when we receive a reward, but when we anticipate it. This is why imagining success or envisioning a reward can be so compelling. Your brain is already flooding your circuits with dopamine, pushing you to act. For example, an athlete might feel a surge of anticipation before a competition. A student might become laser-focused while preparing for an exam, and a creative professional might feel a burst of energy when envisioning the completion of a project. In each case, dopamine is driving the effort toward the reward, not just the enjoyment of it. The role of reward prediction. One key mechanism by which dopamine drives motivation is reward prediction error, RPE. This concept explains how your brain learns which actions are worth pursuing. When an outcome is better than expected, dopamine neurons fire strongly, reinforcing the behavior that led to the reward. When outcomes match expectations, dopamine levels remain steady. And when the outcome is worse than expected, dopamine activity drops, discouraging that behavior. This system is why we develop habits and learn from experience. Dopamine doesn't just respond to rewards. It teaches the brain what is valuable, helping us make smarter choices over time. Dopamine and goal-directed behavior. High dopamine activity enhances focus, energy, and persistence, making it easier to tackle challenges and pursue long-term goals. It supports executive functions like planning, prioritization, and self-control, all of which are critical for success. Without adequate dopamine signaling, even simple tasks can feel overwhelming, and motivation can plummet. Interestingly, dopamine is not only about big rewards, it also responds to small, incremental progress. Completing a small task, hitting a minor milestone, or receiving positive feedback triggers dopamine spikes, creating a sense of achievement that encourages continued effort. This is why breaking larger goals into smaller, manageable steps is so effective. Each small win generates dopamine, keeping motivation alive. Understanding dopamine's role in motivation has profound implications for daily life. Set clear, achievable goals. Dopamine responds strongly to well-defined targets. Celebrate small wins. Each minor achievement reinforces motivation and keeps the brain engaged. Focus on anticipation. Visualizing success or the benefits of a task can boost dopamine and drive action. Avoid constant overstimulation. Overexposure to instant rewards, social media, junk food, can desensitize your dopamine system, reducing motivation over time. Dopamine is the brain's engine of action, turning desire into effort and effort into progress. By understanding and harnessing this hidden driver, we can fuel motivation, build productive habits, and move closer to our goals every day. Dopamine doesn't just drive short-term motivation. It also plays a central role in habit formation. Habits are the brain's way of automating behavior, freeing mental energy for more complex tasks. And dopamine is the chemical signal that tells the brain which behaviors are worth repeating. In other words, it rewards actions that lead to positive outcomes and reinforces patterns over time. The habit loop. The process of habit formation can be broken down into a simple cycle known as the habit loop, which consists of 3 components. Cue, a trigger that initiates the behavior. This could be an external signal like seeing your phone, or an internal one such as feeling stressed or bored. Routine, the behavior itself, such as scrolling social media, exercising, or reaching for a snack. Reward, the positive outcome that reinforces the behavior, often producing a dopamine spike. Dopamine is especially active at the anticipation stage, the moment between cue and reward. The brain essentially says, if I perform this behavior, I might get something valuable. That surge of dopamine makes the behavior feel compelling and motivates repetition. Over time, this loop strengthens neural connections, turning the behavior into an automatic habit. Healthy versus harmful habits. Dopamine doesn't discriminate between beneficial and harmful habits. Healthy habits like exercising, practicing a skill, or completing work tasks trigger dopamine and reinforce constructive behaviors. On the other hand, harmful habits, such as binge eating, gambling, or compulsive social media use, also hijack dopamine pathways, creating cycles that are hard to break. For instance, checking notifications on your phone produces a quick dopamine hit, encouraging repeated behavior. Similarly, eating sugary foods floods the brain with dopamine, reinforcing cravings and habitual consumption. Over time, these behaviors can become compulsive, even when they no longer serve long-term goals. Dopamine and reinforcement learning. Dopamine also underlies reinforcement learning, the process by which the brain adapts behavior based on feedback. When a behavior leads to a positive or unexpected reward, dopamine activity increases, strengthening the neural circuits associated with that behavior. Conversely, if the outcome is negative or disappointing, dopamine activity decreases, discouraging repetition. This learning mechanism explains why habits are so persistent. The more a behavior is reinforced by dopamine, the more automatic it becomes. Even after a long period of not performing the habit, the neural pathways remain primed for reactivation, which is why relapses, both in bad habits and addictions, are common. Practical implications. Understanding dopamine's role in habit formation allows us to design better routines. Start small. Break larger behaviors into manageable steps to generate frequent dopamine spikes. Pair cues with rewards. Associate desired behaviors with clear, positive outcomes to reinforce repetition. Reduce harmful triggers. Limit exposure to cues that prompt negative habits. Leverage anticipation. Visualizing rewards or outcomes can stimulate dopamine and strengthen motivation. Dopamine is not just about motivation. It is the chemical glue that binds repeated behavior into habits. By learning how to work with these neural circuits rather than against them, we can build productive routines, break destructive patterns, and use the brain's natural reward system to our advantage. While dopamine is essential for motivation, learning, and habit formation, it can also be hijacked, leading to addiction. Addiction, whether to substances like drugs and alcohol or behaviors like gambling, social media, and gaming, represents a pathological overactivation of the brain's dopamine system. Understanding this process reveals why certain behaviors feel irresistible and why breaking them can be so challenging. How addiction hijacks dopamine. When we experience something rewarding, dopamine is released in the mesolimbic pathway, also known as the brain's reward pathway. This surge signals the brain to repeat the behavior, reinforcing learning and habit formation. However, addictive substances or behaviors create unnaturally large dopamine spikes, far beyond what natural rewards produce. For example, cocaine blocks the reuptake of dopamine, flooding the brain and creating intense euphoria. Opioids trigger massive dopamine release indirectly by suppressing inhibitory neurons. Behavioral addictions like social media or online gaming exploit the brain's reward system by providing unpredictable rewards, such as likes, notifications, or in-game achievements. Over time, the brain responds to these overwhelming dopamine surges by reducing receptor sensitivity and producing less natural dopamine, a process called downregulation. This creates tolerance, meaning the individual must seek higher or more frequent stimulation to achieve the same effect. The addiction cycle. Addiction often follows a predictable cycle. Craving. Dopamine anticipates the reward, creating a powerful urge. Behavior. The addictive behavior is performed. Reward. A temporary dopamine surge reinforces the behavior. Deficit/withdrawal. Reduced dopamine activity leaves the individual feeling low, anxious, or irritable, prompting further cravings. This cycle explains why addiction can feel like a loop that's impossible to break. Even after abstaining for a period, cues and triggers can reactivate the pathway, leading to relapse. Behavioral addictions. It's important to note that dopamine-driven addiction isn't limited to substances. Behavioral addictions can be equally powerful because they exploit the same reward pathways. Unpredictable, variable rewards, such as winning a game, receiving a notification, or completing a puzzle, create strong dopamine responses, reinforcing repetition. Over time, the brain begins to prioritize these behaviors over natural rewards, like social interaction, exercise, or learning. Implications for recovery. Breaking addiction requires rebalancing the dopamine system. This can involve behavioral therapy, identifying triggers, practicing self-control, and replacing harmful habits with healthier alternatives. Lifestyle changes. Regular exercise, proper nutrition, and sufficient sleep help restore natural dopamine function. Mindfulness practices. Observing cravings without acting on them can reduce compulsive behavior. Understanding the link between dopamine and addiction is crucial. The same chemical that fuels motivation, learning, and goal-directed behavior can also lead to destructive cycles if overstimulated or mismanaged. By recognizing how dopamine operates, individuals can develop strategies to regain control over their behaviors and restore balance to their brain's reward system. Dopamine is essential for motivation, reward, and learning, but when its delicate balance is disrupted, it can have profound effects on mental health. Both too little and too much dopamine activity in specific brain regions are linked to a variety of psychological and neurological disorders. Understanding these patterns helps explain why some individuals struggle with motivation, focus, or emotional regulation. Low dopamine and depression. One of the most common consequences of low dopamine activity is depression, particularly the symptom known as anhedonia, or the inability to feel pleasure. In people experiencing depression, dopamine signaling in the mesolimbic pathway is often reduced, making even enjoyable activities feel dull or unmotivating. This low dopamine state contributes not only to a lack of pleasure but also to fatigue, poor concentration, and reduced goal-directed behavior. Without sufficient dopamine, the brain struggles to anticipate rewards, leaving individuals feeling stuck and unable to take action, even for tasks that were once meaningful. Dopamine and ADHD. Attention Deficit Hyperactivity Disorder, ADHD, is another condition closely linked to dopamine dysregulation. Research shows that individuals with ADHD often have lower dopamine signaling in the prefrontal cortex, a region critical for attention, executive function, and impulse control. This deficiency explains common ADHD symptoms: difficulty sustaining focus, impulsivity, and challenges in completing tasks. Medications like methylphenidate, Ritalin, or amphetamine-based drugs work by increasing dopamine availability in these regions, helping improve focus, reduce impulsivity, and enhance motivation. Excess dopamine and psychosis. Conversely, excess dopamine activity in certain brain areas can contribute to psychotic symptoms, such as hallucinations and delusions, commonly seen in schizophrenia. Hyperactive dopamine signaling in the mesolimbic pathway amplifies the brain's response to stimuli, causing individuals to misinterpret ordinary events as highly significant or threatening. This highlights that dopamine's role in mental health is not just about more or less, it's about balance. Both deficits and excesses in specific circuits can disrupt cognition, emotion, and behavior. Implications for mood and behavior. Dopamine dysregulation doesn't only manifest as clinical disorders. Even minor imbalances can affect motivation, stress response, and emotional regulation. For example, chronic stress, poor sleep, or unhealthy diet can temporarily impair dopamine signaling, leaving individuals more irritable, fatigued, or less motivated. Over time, repeated disruptions can make the brain more vulnerable to depression, anxiety, or addictive behaviors. Strategies to support healthy dopamine function. Maintaining balanced dopamine levels is crucial for mental well-being. Effective strategies include regular exercise, boosts dopamine production and receptor sensitivity. Adequate sleep, supports receptor function and overall neurotransmitter balance. Balanced nutrition. Tyrosine-rich foods and vitamins like B6 support dopamine synthesis. Mindfulness and stress management. Reduces dopamine-depleting chronic stress. Purposeful goals and rewarding activities. Stimulate natural dopamine release and reinforce positive behaviors. By understanding how dopamine contributes to mental health, we can better recognize early signs of imbalance and take proactive steps to maintain emotional, cognitive, and motivational resilience. Dopamine levels and receptor activity are not determined solely by genetics. They are heavily influenced by our environment and lifestyle choices. The foods we eat, how we move, how we sleep, and even the level of novelty in our lives can all affect dopamine production and function. By understanding these factors, we can optimize our brain chemistry to enhance motivation, focus, and well-being. Diet and nutrition. Nutrition plays a central role in dopamine synthesis. The neurotransmitter is made from the amino acid tyrosine, which is found in protein-rich foods such as chicken, turkey, eggs, dairy, soy, and legumes. Adequate levels of vitamin B6, magnesium, and omega-3 fatty acids are also essential, as they help convert tyrosine into dopamine and maintain receptor health. Conversely, diets high in sugar and processed foods can cause short-term dopamine spikes followed by crashes. Over time, These spikes may desensitize dopamine receptors, reducing motivation and reward sensitivity. A balanced, nutrient-rich diet supports steady dopamine signaling and cognitive performance. Exercise. Physical activity is one of the most effective ways to boost dopamine naturally. Exercise stimulates dopamine release and increases receptor sensitivity, enhancing mood, energy, and focus. Both aerobic exercise like running or swimming and resistance training like weightlifting are beneficial. Even short bursts of movement can provide a noticeable dopamine boost, which explains why exercise often improves productivity and motivation. Sleep. Sleep profoundly impacts dopamine receptor function. During adequate rest, the brain restores receptor sensitivity and maintains proper neurotransmitter balance. Chronic sleep deprivation, on the other hand, reduces dopamine receptor availability, leading to fatigue, lack of motivation, poor decision-making, and impaired learning. Prioritizing regular, high-quality sleep is therefore essential for optimal dopamine function. Novelty and challenge. Dopamine thrives on novelty and challenge. Engaging in new experiences, learning new skills, or tackling tasks outside your comfort zone stimulates dopamine release. This explains why exploring new hobbies, traveling, or setting ambitious goals can be so motivating. Novelty triggers dopamine by signaling that the brain may encounter a valuable reward, reinforcing curiosity and exploration. Stress and environment. Chronic stress negatively affects dopamine signaling. High cortisol levels can reduce dopamine production and receptor sensitivity, leaving you feeling unmotivated and emotionally drained. Conversely, supportive environments that encourage learning, achievement, and social connection can promote healthy dopamine activity. Spending time outdoors, practicing mindfulness, and maintaining meaningful relationships all contribute to balanced dopamine levels. Practical strategies. To optimize dopamine naturally, eat a tyrosine-rich, nutrient-dense diet to fuel production. Engage in regular physical activity, alternating aerobic and resistance exercises. Prioritize 7 to 9 hours of quality sleep per night. Seek novel experiences and challenges to stimulate motivation. Reduce chronic stress through meditation, breathing exercises, and social support. By intentionally shaping your environment and lifestyle, you can support dopamine function, improve mental clarity, boost motivation, and reduce the risk of addictive or compulsive behaviors. Dopamine is not just a chemical, it's a dynamic system that responds to how we live, giving us the power to influence our brain chemistry and ultimately our behaviors. Dopamine is not just a passive chemical. It can be actively harnessed to enhance motivation, focus, and overall well-being. By understanding how dopamine works, we can structure our daily routines, goals, and environments to support its healthy function while avoiding overstimulation and burnout. Set clear, achievable goals. Dopamine responds strongly to anticipation and progress. Breaking larger goals into smaller, actionable steps generates frequent dopamine spikes, reinforcing motivation and sustaining effort. For example, if your goal is to write a book, focus on completing one chapter or section at a time. Each small win produces a dopamine surge, creating a positive feedback loop that encourages continued action. Celebrate small wins. Don't wait for major milestones to reward yourself. Even minor achievements, like completing a task or learning a new skill, stimulate dopamine release. These small rewards reinforce your progress and keep motivation high. Simple celebrations, a short break, a cup of tea, or noting your accomplishment, can make a big difference. Avoid dopamine overload. Constant exposure to high-stimulation activities, such as social media, video games, or junk food, can desensitize dopamine receptors over time. This reduces motivation and the ability to enjoy natural rewards. Structured use of these activities, combined with regular breaks, can prevent overstimulation and maintain the brain's sensitivity to dopamine. Use visualization and anticipation. Dopamine spikes most strongly in anticipation of a reward. Visualizing the completion of a task or imagining the benefits of achieving a goal can increase motivation before you even take action. Athletes, entrepreneurs, and creatives often use this principle to prime their brains for success. Engage in physical and mental exercise. Regular physical activity boosts dopamine production and receptor sensitivity, enhancing energy, mood, and focus. Likewise, challenging your brain with new learning, problem-solving, or creative tasks stimulates dopamine and reinforces neural pathways. Combining physical and mental exercise is particularly effective for sustaining motivation and cognitive performance. Practice mindfulness and stress management. Chronic stress depletes dopamine and impairs receptor function. Mindfulness practices, meditation, deep breathing, and yoga help regulate stress, keeping dopamine pathways balanced. By observing impulses without immediately acting on them, you can reduce compulsive behaviors and maintain motivation for meaningful goals. Implement dopamine fasting strategically. Dopamine fasting, temporarily abstaining from highly stimulating activities, can help reset the brain's reward sensitivity. Short periods without social media, video games, or sugar allow natural dopamine levels to recover, making ordinary rewards more satisfying and reinforcing healthy habits. Optimize sleep and nutrition. High-quality sleep restores dopamine receptor function, while a nutrient-rich diet provides the building blocks for dopamine production. Tyrosine-rich foods, vitamins like B6, and omega-3 fatty acids all support healthy dopamine signaling, ensuring your brain has the tools to maintain motivation and focus. Dopamine is not just a chemical. It's a tool you can harness to shape behavior, reinforce habits, and achieve your goals. By setting clear objectives, celebrating progress, managing overstimulation, and supporting your brain through lifestyle choices, you can turn dopamine into a powerful ally for productivity, well-being, and long-term success. Dopamine is often celebrated as the chemical of motivation, reward, and pleasure. It drives achievement, fuels ambition, and reinforces positive habits. Yet, paradoxically, the very system that empowers human progress can also become a source of vulnerability, leading to addiction, compulsive behaviors, and burnout. Understanding this paradox is key to mastering dopamine's influence on our lives. Motivation and vulnerability. Dopamine's primary role is not to make us feel pleasure. It is to create desire and drive. This anticipatory spike motivates action toward goals, whether that's completing a project, learning a new skill, or pursuing a long-term dream. However, this same mechanism can be hijacked. When artificial or excessive rewards, like drugs, social media, gambling, or processed foods, trigger massive dopamine surges, the brain begins to prioritize these behaviors over natural rewards. This is why seemingly simple pleasures can become compulsive. The system designed to motivate us toward meaningful goals can instead enslave us to short-term gratification. In essence, the chemical that pushes us forward can also pull us off course. The tolerance effect. Repeated overstimulation of dopamine pathways leads to tolerance, a decrease in receptor sensitivity. The same activity that once produced excitement or motivation gradually becomes less effective, requiring higher levels of stimulation to achieve the same effect. This applies to both substances and behaviors. For example, an individual may start with casual social media use but gradually feel compelled to check notifications constantly, chasing the same dopamine rush. The downside of constant motivation. Even natural rewards carry risks. High-achieving individuals who rely heavily on dopamine-driven motivation may find themselves in a state of chronic pursuit. While goal-directed behavior is productive, excessive chasing of outcomes can lead to stress, anxiety, and burnout. The brain's reward system, when overactivated, can paradoxically reduce enjoyment, leaving individuals feeling hollow despite external success. Balance is key. The paradox of dopamine highlights that it is not about more dopamine, but about balanced dopamine activity. Healthy dopamine function requires periods of stimulation and recovery, small achievable rewards, and mindful regulation of habits. Engaging in overly stimulating activities without moderation can desensitize the system, while intentional, goal-directed behaviors with meaningful rewards strengthen motivation without the negative side effects. Practical insights. Moderation matters. Enjoy rewards, but avoid over-reliance on high-stimulation behaviors that flood the system. Structured goals. Break down large goals into smaller, achievable steps to maintain consistent motivation. Recovery periods. Allow your brain to reset through sleep, rest, and temporary breaks from intense stimulation. Mindful awareness. Recognize when desire is being hijacked by short-term rewards rather than meaningful goals. Dopamine is both a driver and a double-edged sword. It can inspire monumental achievements or trap us in cycles of compulsive behavior. By understanding its paradoxical nature, we gain the power to harness dopamine wisely, leveraging its motivational force while protecting ourselves from its potential pitfalls. Mastering this balance is not only a matter of neuroscience, but a cornerstone of productivity, mental health, and personal fulfillment. Dopamine is far more than a feel-good chemical. It's the silent architect of human behavior. It fuels our drive to explore, create, and achieve, but it can just as easily trap us in cycles of craving and dissatisfaction. The same system that propels us toward greatness can also, when misused, lead to burnout, addiction, and emotional emptiness. Throughout this journey, we've seen that dopamine's power lies in its anticipation, not pleasure. It motivates us to act, to seek progress, to strive for something beyond the present moment. But when overstimulated through constant digital notifications, junk food, or addictive substances, the brain's reward system becomes distorted. What once felt rewarding begins to lose meaning, and genuine satisfaction fades. The key to mastering dopamine is balance. When we use it intentionally, by setting achievable goals, celebrating small wins, maintaining healthy routines, and allowing periods of rest, we can transform dopamine into a lifelong ally. It becomes a source of clarity, focus, and fulfillment, rather than a relentless pursuit of fleeting highs. True mastery of dopamine isn't about chasing constant excitement. It's about cultivating a rhythm between effort and recovery, stimulation and stillness, pursuit and presence. This balance allows you to stay motivated without becoming enslaved to the next rush of pleasure. In a world designed to hijack your attention and exploit your dopamine system, understanding how this neurotransmitter works gives you the power to reclaim control. You can design your environment, habits, and mindset to work with your biology, not against it. Ultimately, dopamine doesn't have to dominate you, it can empower you. When you learn to guide it with awareness, you gain not only productivity and motivation, but also a deeper sense of satisfaction and peace.